Good morning, everyone. So welcome to my YouTube channel, Math Saktaram. So today we are going to see 14th lecture on functions of bounded variation. Okay, till now, if you have not subscribed my YouTube channel, subscribe it immediately for such type of interesting topics. So let's start today's session now. In last lecture, we have studied positive and negative parts of a functions of bounded variation. Okay, note that sometimes positive part P is called positive variation function, and negative part Q is called negative variation function of F, where F is function of bounded variation. Okay, so positive and negative parts of a function of bounded variation are respectively called positive variation function and negative variation function respectively. Okay, so we'll do one remark. Let F close interval AB to R be a function of bounded variation. Then first, so this is remark 1. Sorry, not. So then F is continuous if and only P and Q are continuous. Okay, let's see its proof. We know that F is continuous if and only if BF is continuous. Okay, yes, BF is continuous. Now first assume that F is continuous. Then this implies BF is continuous. Okay, so this implies BF is continuous. So now what we have? We have F and BF are continuous. So this implies their sum will be continuous and their difference will be continuous or continuous. Okay. Now multiplying with a number, scalar number, they will remain continuous. So this implies 1 upon 2 BF plus F and 1 by 2 BF minus F are continuous. But 1 by 2 BF plus F is nothing but P. This is equal to P and this is equal to Q. So this implies P and Q are continuous. Okay. Now we assume converse part. Conversely, assume that P and Q are continuous. But P and Q are, so this implies P and Q are continuous. But P and Q are of the special form. What are they? P is equal to 1 by 2 BF plus F and Q is equal to 1 by 2 BF minus F are continuous. Okay. So this implies 1 by 2 BF sum of difference of continuous function is continuous and sum of continuous function is continuous and 1 by 2 BF plus F BF minus F are continuous. But what is this? What is this will be cancelled out. So this is F. And what is this? This will be cancelled out. And BF are continuous. So I need only one thing. So this implies F is continuous. Okay. So finally, I can write a corollary. Let have closed interval AB to R be a function of bounded variation, then F is continuous if and only if BF is continuous if and only if P and Q are continuous. Okay. So F is continuous if and only BF is continuous, already done. And we have done that F is continuous if and only P and Q are continuous. So it means F is continuous if and only BF is continuous if and only P and Q are continuous. Okay. All three statements are equivalent. Okay. Now we will do, using this fact, we will do some question only. Okay. Question. compute the total variation function. Total variation function or variation function same thing, or I can write in slash variation function. Positive, comma positive variation function and negative variation function of f given by fx is equal to 3x square minus 2x cube or whole x in this range. Okay. So do this. Now this is a polynomial function. Obviously it will be a function of bounded variation. No need to check on any closed interval. So it will be on minus 2 to 2. Now we will find where it is increasing, where it is decreasing, monotonically increasing, decreasing, all this thing. So what is the f is given this? So first we will calculate its derivative. What is the derivative? 6x square, sorry, 6x. 6x square, sorry, 6x minus 6x square. So when the derivative is 0, this implies 6x minus 6x square is equal to 0. I can take 6x common, so 1 minus x is 0. Okay. So where derivative is 0, this implies x is equal to 0 and x is equal to 1. So derivative vanishes at x is equal to 1, x is equal to 1. Now f dash x is equal to 6x 1 minus x it is. Okay. So on this interval 0 to, on the interval minus minus 2 to 0, what we have? We have the derivative is non-negative. Sorry, derivative is negative. Okay, derivative is non-positive. F dash x is less than equal to 0 for all x belongs to closed interval minus 2 to 0. So in by mean value theorem, this implies f is increasing, f is monotonically decreasing. Monotonically decreasing on the closed interval this. Okay. Now what about 0 to 1 interval? What about now check on this interval on I am taking okay 1. So what is the derivative? Derivative is non-negative for all x belongs to 0 to 1. So this implies f is monotonically increasing on close interval 0, 1. Okay. So -2 to 0 it is monotonically decreasing. 0 to 1 it is monotonically increasing. Now on 1 to 2. So 1 to 2 you see that f dash derivative will be less than equal to 0. Why? Because you see the factor 1 minus x. So when you will go beyond 1, it will be 1 minus x factor is negative and rest factors are positive. So it will make it non-negative. Okay. Overall, f belongs to 1 to 4. So this implies f is monotonically decreasing on closed interval 1 to 4. Okay. Now, next what we will do, next I will calculate my on this interval on -2 to 0. F is monotonically decreasing. So first I will calculate my variation function on this. Okay. So for x in this range, we have VFX is nothing but VF -2 to x. But function is monotonically decreasing. How we will write f -2 minus fx? Because the variation function, total variation of a monotonically decreasing function is given by this form. Initial point minus that point, final point. But we are taking x here. X is variable, but ultimately it is final point. So f valued at -2 minus fx. What is -2? What is -2 value here? -2 value is here. So 3 minus 2 का square -2 -2 का cube. Okay. Minus you put the value of that function. 3x square minus 2x cube. So after solving it, what you will get? You will get this is 12 and this is okay 16 minus 3x square minus 2x cube. So this is 28 minus 3x square plus 2x cube. Okay. So PF function is this on closed interval -2 to 0. Now on the interval on this interval 0 to 1, f is monotonically increasing. Monotonically increasing. Okay. For x such that x in this range, okay, we have what is BFX, that is BF 0 to x Okay, 0 to x it is. But function is monotonically increasing. How to write then? The final point and the initial point. So what is this? This is 3x square minus 2x cube. And what is this? 3 0 square minus 2 0 cube. Okay. So this is 3x square minus 2x cube. Okay. So this implies dfx is equal to 3x square minus 2x cube on the closed interval 0. Now on this interval, closed interval 1 to 2, f is monotonically decreasing. Monotonically decreasing. So for x such that I am taking x in this range, we have bfx is equal to because function is monotonically decreasing 1 to x, but this I can write because function is monotonically decreasing f1 minus fx. f1 it is 3 1 का square minus 2 1 का cube minus 3x square minus 2x cube. 3 minus 2 minus 3x square minus 2x cube. 1 minus 3x square plus 2x cube. Okay. So this implies bfx is equal to 1 minus 3x square plus 2x cube. So what we got actually? Finally, we got, so we have bfx function is equal to, it is 28 minus 3x square plus 2x cube on if on this interval minus 2 to 0. And this is and what is on interval 0 to 1? On 0 to 1 it is 3x square minus 2x cube. 3x square minus 2x cube on minus 0 to 1. And on it is 3x square plus 2x cube on 1 to 2. Because I am involving 0 here and 0 also here, 1 here and 1 here. Because I know that function is going to be continuous because f is polynomial function and polynomial functions are continuous. That is why I am defining 0 2 times and 1 2 times, because I am know that if I will calculate df at 0 from above interval, it will give you value 28. And if I will one minute, let me check it. f1 minus f0. So let me check, maybe some mistake is here. So f minus 4, f is 12 and 16 minus 2 to 0, 0 to 1. 0 to 1 it is monotonically increasing. Fx. Okay. Zero to x. Okay. Okay. So let me check 1 minute. It is minus 2 to 0, 0 to 1. At minus 2, 0, S is monotonically decreasing. Okay. So we have minus 2, evaluated minus 2. So it is minus 8, 16, 3x square. This is okay. And then x is monotonically increasing for x such that in this range we have monotonically increasing. So fx minus f0, 3x square. Okay. So okay. So one. I made a mistake here. So let me correct it. So I am writing it again. So up to this it is correct. So one thing I am forget. Okay, here. So let me correct it here. Now so what we have calculated actually till now, we have VFX is what is this 28 minus 3x square plus 2x cube on the interval this minus 2 to 0. Okay. And VFX is this 3x square minus 2x cube on this interval 0 to 1. Okay. And BFX is this in this interval. This is it was on that 1 to 2. 1 to 2 it was 1 minus 3x square. 1 minus 3x square 2x cube on 1 to 2. Okay. Okay. So now I want my function bf. I have calculated, you see that bfx, but bfx is always calculated. So I am writing in a detail. Actually, what we have here, there should be no confusion at all. There is some thing understand to here. What is actually this? This is we have bf minus 2x. X belongs to where x is belonging to on this interval. Okay, and what is bf? 0x for all x belongs to x belongs to this. And what is this? This is bf 1 to x for all x belongs to this. Now I need so what is from here, what is this? bf minus 2 0. What is this? Can anyone tell me? This is 28 because I am taking 0 here. I will put 0 here. 28 minus 0 plus 0, that is 28. What is bf 0 1? Put the value of 1 here. Minus 2. Okay, that is 1. Okay. Now I need so I need this value bf minus 2 to x. If I am taking, so this is bf minus 2 at 0 plus bf 0 to x. If I am taking value from this interval 0 to 1, how it will calculate it? It is 28 and it is 3x square minus 2x for all x belongs to closed interval 0. Okay. Now I need bf minus 2x. Okay. So I can write it bf minus 2 to 0 plus bf 0 to 1. Okay. I can write it 0 to 1 plus bf 1 to x for all x belongs to 1 to 2. Okay. So what is this I can write? I can write it bf minus 2 to 0 plus bf 0 to 1 can write it. Okay. This is equal to this. Okay. Now what is this? bf 1x for all x belongs to 1 to 2. Okay. So now this is equal to 28 and this is equal to, what is this equal to? This equal to 1 and this is equal to 1 minus 3x square plus 2x cube for all x belongs to 1 to 2. So after solving it, what you will get? 30 minus 3x square plus 2x cube. Okay. Okay. So this is, so I am writing my function. So this implies BFX is equal to, what is this? This is 28 minus 3x square plus 2x cube on this interval. Okay, I am also correcting above. Let me correct above because the symbol was something. So what was this? Let me correct this. BF, this was minus 2 to x. BF minus 2 to x. BF 0 to x. BF 0 to x. BF 1 to x. BF 1 to x. Okay. So we have already calculated this. Then we find, we write everything here, and then we calculated BF minus 2x where x belongs to closed interval 0, 1, and we calculated BFX minus 2x where x belongs to 1, 2. Okay. So BF minus 2x, x belongs to minus 2 to 0 is already calculated. No need to write, okay? Because this is here. So I am writing here all these things here. What is 28 minus x square plus 2x cube? Okay. Here is cube. Okay. (28) plus 3x square minus 2x cube. And this is 30 minus 3x square plus 2x cube for all x belongs to minus 2 to 0 for all x belongs to 1, 0 to 1 for all x belongs to 1 to 2. Because f is given that continuous, this df function is also continuous. You can check. How to check? F0 you check. At 0, from here you will get value 28. From here you also get value 28. From here you at 1 you are getting value 29. From here you are getting value at 1, it is 29. It's same. Here from 29, from here you are also getting 29. So BF is also continuous because it is given that F is polynomial function that is continuous. Okay. Now F is actually Fx equal to this 3x square minus 2x cube on so variation function we got. Now we are to calculate variation function Vfx we got. Now we need to calculate positive and negative parts. Okay. So Fx is given this on minus the overall minus 2 to overall x belongs to minus 2 to 2. Okay. So what is P? Px is equal to 1 by 2 Bfx plus Fx. So Fx has same value on throughout the interval is given by single formula. Okay. Now what is this? Then what is Px? Px is equal to, you add Fx plus Fx, then what you will get? So these terms will be cancelled out. So what you will get? You will get 14 because 1 by 2 is here. So you will get 14 here. 14. Okay. For all x belongs to minus 2 to 0. Now, what about on the interval 0, 1? What you will get? So you will add this. So you will get 14 plus 3x square minus 2x cube. For all x belongs to 1 to 0 to 1. Okay. And what about close interval 1 to 2? You will get, add this, they will be cancelled out. 15 you will get. 15. Okay, so positive part is this. Now, and finally, what we are going to find? Qx. Qx is equal to 1 by 2 Bf minus F. So what you will get? Qx is equal to Bf minus F you are going to do. What is F? So you will subtract. So this will be 14 minus 3x square plus 2x cube. For all x belongs to minus 2 to 0. Okay. Now, subtract it again on the closed interval 0, 1. What you will get? This will be minus. So 14 it will be here. 14 for all x belongs to 0 to 1. And what will be final? On final interval 1 to 2. So subtract it. Okay. So you will get 15 minus 3x square plus 2x cube. So 15 minus 3x square plus 2x cube for all x close interval 1 to 2. Okay. So you can check this P and Q are continuous. At 0 it is giving value. I'm seeing the Q. At 0 it is 14. At 0 it is 14. And at it is 1 at 14 above. And from the middle one interval 0 to 1. And last one interval 1 to 2. It is giving at 1. It is giving value 14. Yes, this is continuous. Similarly, you can check P is continuous. So we have calculated variation function, that is total variation function, positive part P and negative part Q. Okay. So today's lecture up to this. If you have any problem related to this lecture, you can comment me on my YouTube channel. Thank you very much for today's lecture. Like, share, and comment. Subscribe my YouTube channel. Okay. Thank you very much.